everyone, this is Craig Trumpy with ATech and Asset Scan. Today I'm going to talk about extending reliability with IIoT with a video on artificial intelligence for setting ultrasonic alerts. So here I'm logged into our Asset Scan AIP, ATech Intelligence Platform, and I'm going to go up to Views, and I'm going to open our Help on Ultrasonic Alerts. Here's a guide that we'll go through today to help us understand how we preset these alerts. So scrolling down in this document, here is our model. What it all is centered around is setting the alerts based on RPM. And so this is a log-to-log chart. And the first thing you'll notice is that these lines here are flat. And what this is showing is that from 600 RPM to 6,000 RPM, we can use the same alert level of 6 Gs for minor, and then 12 Gs for warning, and 18 Gs for critical. When the speed of the machine goes faster, we raise the alert limits, and when the speed of the machine goes slower, we lower the alert limits. That's all there is to this alert limit rule set. What we call this is our artificial intelligence for setting alert levels. As an artificial intelligence, it's really just taking a set of rules that we use in past practice as humans and developing the rule set so that the machine can do that work for us. Next, let's review some of the case studies around this, provide our feedback loop on how well this model is working. So for 1800 RPM, we said that's between 600 and 6000 RPM, so we can use the standard 6, 12, and 18 G limits. Here's 3 case histories that provide the feedback that this is a valid rule set. You'll notice that these 3 different bearings have 3 different faults. The one on the left is an outer race wear fault. The one in the middle is an inner race fault. And the one on the right is a defect in one ball of the bearing. Starting back to the left, the outer race fault was reading 16 Gs. This was a 1200 horsepower motor and a vacuum pump in a paper mill application. 16 Gs drove the customer to make a decision to change out this motor on their schedule, not the pump schedule. This was a significant effort to align your labor to change out a motor of this size, and so the alert provided them that early warning, that leading indicator, so that they could make the plans accordingly and change this pump or motor out on their next planned wash-up. The center bearing is in a wind turbine. It's a 1.6 megawatt wind turbine, and 17 Gs was the reading in this defect in the inner race. This was on the generator bearing, so this is one of the bearings on tower that can be replaced on tower without having to bring in a crane and without having to change out the entire generator. So what this customer did upon seeing the 17 Gs, they did the prescriptive task of field inspect and lubricate. On field inspection, they opened the bearing housing on the outboard of this generator. They noticed the grease had become discolored, turned black or dark gray with metal debris. They took a borescope and were able to inspect the bearing, found this defect, and so knew with confidence that they could replace this bearing and remedy the problem. So again, providing that early or leading indicator, allowing them to do the field inspection, confirm their plan, and schedule their repair. The last example is a 300 horsepower motor on a utility air compressor. This one was reading considerably high, 42 Gs, and so I get questions here of why is that so high, and that defect does not look considerably more damaging. And so what we refer to is anything above 18 Gs is a critical. And so we don't distinguish, get too excited about how high that number is over 18. At this point, what we're suggesting is that you're dealing with days of runtime, and so we want to go ahead and drive the right behavior. And in this case, they did an inspection on this machine. They do have redundancy in this case, so they could move to a backup compressor. They did move to a backup compressor eventually. They waited to a outage, their 4th of July outage, to change out this motor and this bearing. And so they could, again, plan for it, schedule it, and do this under their time frame, not the machine's time frame. Scrolling down in this document, we are now looking at our slower speed examples. And so this is a 76 RPM example. And what we do is we go to 76 RPM on the x-axis. We come up to that minor level of yellow, and we see that's a 1G alert limit. And then likewise for the orange and red, we set 2 to 3 Gs. This is the bearing defect that was found on this asset. And what's more interesting is that this tooth should have a lot more metal here. In fact, 70% of that tooth is wore. So this defect was shown as 2.9 Gs, and again, just right under a critical, which provided that leading indicator for the client to order the gearbox, in this case coming from Europe, and plan and schedule the repair. So now scrolling down to our last example, this is a slower speed yet. This is a 33 RPM example on a Trunnion bearing on an air dryer in an ethanol plant. And what this client did is they installed the asset scan on one of their bearings and monitored it for some time, and then moved it to a second bearing with the intention to move through the bearings on this dryer. Upon moving it to the second bearing, they saw an alert condition. The prescriptive task on a minor alert on ultrasonic is to field inspect and lubricate. They greased this bearing, and the alert level or the readings went down, indicating the problem or friction had subsided. So going back here a second, arriving at these alert limits, again we use the AI model and the RPM to set the 0.6, 1.2, and 1.8 G levels. And the alert here was a 1.G lubrication defect, so just high into the minor. And again, they were able to resolve this prior to any damage occurring to that bearing. Interesting point here is that the asset scan has a store and forward capability. This is a remote location in a steel building, and the customer was concerned the cellular would not get out. We went ahead and deployed this, knowing that he could pull that box out of that steel building, get reception, and the data would flow. In reality, the text message was able to get out from inside this building. It does not need much, doesn't need a full strength that you need for voice, and it will retry to get that data out. If you have any questions, feel free to reach out to us at assetscan.com. Thanks for joining us today.